Good morning, everyone, and welcome to our webinar on innovations in pipeline protection. My name is Adam Connors. I'm Vice President of Sales and Marketing here at PipeSac, and I'll be your moderator for today's session. I'd like to introduce our presenters, Jeff Connors, PipeSac's founder and CEO, and Travis Cotterill, PipeSac's lead engineer. Jeff graduated in 1980 with a degree in civil engineering from the University of Waterloo. He spent his first 18 years in the oil and gas industry as a design engineer and project manager on some of the biggest diameter pipelines in North America. Since then, Jeff has designed and patented numerous pipeline protection products that have been used across the globe for the last 20 years. Travis joined PipeSac in May of 2019 for an engineering internship with the University of Western Ontario. Once Travis graduated in 2021, he came back to PipeSac to begin his EIT journey with PipeSac. Travis is now PipeSac's lead engineer and helps design new products, innovate current ones, and manages testing and quality control. We're going to have a 15-minute Q&A after the presentation, so feel free to use the Q&A tab at the top of your screen, and we'll answer all relevant questions at the end of the webinar, which should be about 30 minutes, with the Q&A period afterwards. For better viewing of the slides, if you want to click the pop-out button at the top of your screen, you'll be able to see our slides a bit better and read the text on it better. We're going to be recording this webinar, so if you're interested, send me an email at aconnors@pipesac.com, and we'll have a recording available in about a week or so. So without further ado, let's begin, and I'll pass things over to Jeff.
All right, thanks, Adam. Good afternoon or good morning, everyone. Thanks for coming. I appreciate your time like this. The flip over to the agenda if I can. Oh, that's working. Oh, I go this way. Sorry, guys. Nothing's happening. What's that? There we go. Who's that? Travis? Rascal. Anyways, that's just our cover page. Maybe Travis flip to the agenda, and I'll speak to what we're going to be talking about today. So this is our agenda for the next hour. I'll introduce PipeSac. To talk a little bit about the industry concerns from PipeSac's perspective. As well as give a brief history on rock protection itself. Then Travis will take over and give you basically the meat of the presentation of the webinar and talk a little bit about our Rockshield. As mentioned, as Adam mentioned earlier, we'll have a Q&A at the end, and certainly I believe you can actually submit them as well, questions along as we go along. So I'll try and go to the next slide, or is Travis going to do that? Travis, next slide, I guess. There we go. This is kind of who is PipeSac? We are a pipeline protection company. Is what we do. Everything we do evolves around one premise. We believe that every product that is in permanent contact with pipelines should be engineered. What I mean by that is that they stand up to rigorous engineering design and testing. Following industry standards. Wherever we can. Sometimes there's not a standard for what we're designing, so we'll actually help the industry develop standards for testing. Next slide, Travis. You can. Now this, as most of you know, PipeSac started off as a buoyancy control company back in the late 80s. We developed the very first geotextile fabric weight that you fill with gravel ballast. This we certainly still have this product today. It's probably still our biggest seller. It's basically changed the industry back in the day on getting rid of the concrete set-on weights. We went on for a couple decades before we decided that we should kind of look at the trench, the rock in the trench, and we developed the pipe pillow, which was initially meant for in the trench use only, to support the pipe up off the bottom of a severely rocky trench. So the sand bedding and patty can be poured in one shot. Pipe pillows are now being used above ground a bit, but initially and to this day, they're still mainly used in the trench and support a pipe off a rocky bottom. Then we went for quite a while, a couple decades until I guess around 2022, when we decided, okay, let's start looking at protecting the coating itself from rock. Again, what we do is pipeline protection. So we initially came up with Pipe Defender, which is a more extreme version of a rock shield. It's for larger rocks, where you just basically cannot get any sand bedding or padding available. And then most recently, Rock Stop. Again, back in 2022, we developed the Rock Stop product just to kind of give the industry a better method of protecting their pipelines. Next slide, Travis. Sorry about that, Travis. Rock Stop. There's our slide. A Rock Stop is just basically it's a needle punched. Oops, a needle punch product. There we are, an industry concern. These are basically what we consider industry concerns. Again, this is from PipeSec's perspective. When we design our products, we keep all these four concerns top of mind, and basically in this order, really. Certainly safety is a big one. Whatever products we develop, we want to ensure that they are safer or as safe or safer than what they're doing today. We certainly don't want to, safety comes is a big, very first component. And of course, performance. The products we design have got to, perform as good or better than what's out there now. I think all of our products actually perform better than what's out there now. Um, Cost and availability, of course, are a concern. They've got to be competitively priced and they've got to be available. I think availability is the more important of the two. Contractors, when they've got a pipeline going, you've got to make sure your products are available for them almost at a moment's notice. Most of you probably realize or understand that concept that when pipeliners want something, they need it quickly. So that was also a big component. And for efficiency, I guess that kind of ties into cost and availability as well. The products have got to be efficiently installed, safely installed, they using current equipment, so we don't like to have necessarily have any specialized equipment to install our products. They've got to be able to be used with today's equipment. Next slide, Travis. Now I'll talk a little bit about coatings. This is probably not the best picture to be shown, but just the coatings evolved along have probably been the biggest change in the industry over the decades, along with steel pipe itself. But coatings, initially back in the early days of pipelining, early 1900s or so, went from a hot wax that they basically poured over the pipe with actually a craft paper on it. On the right of way itself. So pipe always came out bare and they put wax on it, or that evolved into a coal tar coating that was again put on the pipe hot. And both these coatings were good in their day. They tended to they did a good job coating the pipe, but they tended to get kind of crusty, and cathodic protection systems weren't quite up to snuff at that time. As things evolved, you basically got into tape coatings, which again were applied initially on the right of way, following welding and of the pipe. These huge tape machines would go over your pipe and put I don't want to use a brand name, but a polycon type of plastic type tape over the pipe in a like a rolling fashion. It's quite something to see. That worked out quite well for decades. Then as the pipelines got bigger and bigger, that coating mechanism became tougher and tougher to do. And basically the bottom line was too is as pipelines got bigger, there's more steel there, and coating them on the right of way was pretty darn impractical. It was time consuming. So pipelines started to be coated in the factory. Initially with the yellow jacket type coating, and they eventually evolved to a fusion bond epoxy, which we see mostly today. It's a great coating, very consistent. But as you can see in these pictures, you still have to watch out for any kind of defects. Next slide, Travis. This, certainly epoxy coatings are very tough, but depending on the rocks, you can certainly get some defects like this happening. So there needs to be, in certain situations, there needs to be another coating, an external coating applied to protect the pipe specifically against damage like this. And this is where Rockshield's come into play. Next slide, Travis. Yeah, this is okay. I'm going to quickly go over, hopefully quickly, a little bit of the history on rock shields themselves. I talked a little bit about the coatings, but rock shields back in the early 1900s, any kind of protection was really from sand bedding and sand padding, sand bedding under the pipe, sand padding on top of it. The picture here is a sifting machine. They didn't do that back in the 1900s. It was all basically hauled in, but that was the means of protecting a pipe, and you can still see that today. So it's a method that has lasted this long. But next slide, Travis. Here's a shot of some wood lagging, which was picked up in the late 50s as well for more extreme protection. Again, I've got these on the top of the line. You're going to see a couple extreme protection systems that aren't considered a rock shield per se, but they're for areas where you just cannot get sand bedding or sand padding to the site generally, or you're in a wet area where sand bedding just won't stay. Then the 60s. Heavy tape. I talked a little bit about earlier for coating the pipe. A heavy tape that went on top of that tape that was put on the pipe for coating. A heavier version was wrapped on the pipe, and again that was more for rock protection, small rock protection, but also abrasion as well. So they used to put this stuff on, road crossings and even the odd road bore. This stuff will give some good protection. The only problem with it, well, not only problem, but one of the biggest problems with tape is if areas which are very infrequent, but areas where there is incomplete bonding to the pipe itself, or there's a tenting occurring, you could potentially get some kind of corrosion happening there. Stress corrosion cracking, some of you may have heard that. That was an old terminology that was a big problem for a number of years. And mainly it was a problem where there was taped coatings that tented and there was the right pH and the right pressure in the pipe to cause stress corrosion. So tape coatings, mainly for large transmission lines, are not used anymore. It's just the smaller 8-inch pipelines, maybe you might see more of that, but the larger stuff, you don't see tape coatings anymore. I think I've got control here, Travis. Maybe I do. Maybe, oh, there we go. In the 70s, you saw a little bit of thin film concrete coating came up. So this isn't for buoyancy control. This is like 1 or 2 inch concrete coating that's basically impinged on the pipe. Was a method to replace wood lagging. So again, this is was a more extreme coating protection, and it's still around today. They all have issues. Everything does, it seems. So wood lagging, it tends to rot and be a problem over time, where concrete coating tend to be an issue of cost, which is very expensive, but also hauling and installing. You're now working with a pipe now that isn't even welded yet. That's heavier, a lot heavier. So it caused some issues. And it was difficult to bend pipe with this type of coating. So typically, pipe's hauled out, and you're going to bend it. You're going to weld it and then bend it to match the terrain, or even bend it first and then weld it. But with this stuff on, you had trouble bending it. So then in the 80s, the stranded rock shields started coming out. The plastic PVC stranded material, I'll talk a little bit about it, and the plastic grids came out. And I'll talk a little bit about them. And they're still popular today. They're a covering that is applied after the pipe is welded and bent. So it's or bent and welded. So it's handy that way. It's put on just before you install the pipe in the trench. And then there's engineered pipeline lagging, which is a pipe sack product called Pipe Defender. And again, it's to replace concrete coated pipe and wood lagging. It's more for extreme situations where you have a problem with rogue rocks of a large size that could drop on the pipe, or you have areas where you just can't get sand bedding and padding to the pipe. This is stuff you want to put on it. And then later on in 2022, we came out with Rock Stop, which is what we're gonna talk about today. Next slide, Travis. Oh, sand bedding. Okay, well, just a little bit of a little slide showing how there's sand bedding and padding pipelines. Now, again, the problem with sand bedding, it's slow. It can be a slow process. This is actually both these. There's an Aussie pattern on the left and a sifting machine on the right. These just go over the spoil pile and sit out the fine material and put it on the pipe, which is a pretty efficient way to do it. The only concerns that we have, well, the biggest concern we have with this type of bedding is the problem of it diluting over time, especially if groundwater does get back in the trench. It has been known to dilute away from the pipe, and now you're exposing in the worst case scenario, you're exposing the bottom of that pipe to a rocky trench. In general, this works very well, but there are those instances. So typically, sand bedding like this and sand padding is used in conjunction with a rock shield. This is just the rock shield is put on as the long term, more long term protection, I think. Next slide, Travis. So yeah, this is just so I guess we've kind of gone over this. Why use a rock shield? Certainly it's just to protect your coatings. The big difference is that you have a rock shield which protects your coating from individual rocks, really up to 6 inches, even 8 inches, from damaging the coating and causing a defect. What rock shields don't do is they don't protect the pipe from denting. That's when you get into the pipe defenders and this more heavy duty material. If you're looking at only 2 inch and smaller rocks, a rock shield certainly is the way to go. And there's a lot of cost advantages on using a rock shields because you really don't need to sand pad it as extensively as you may if you didn't use a rock shield. Next slide, Travis. So these are the two have been the two common alternatives from I would say from the early 80s up till now. A stranded PVC rock shield, yellow one, and an open grid plastic rock shield. Next slide, Travis. Now the randomly stranded rock shield is the yellow one on the left is extruded and extruded in fibers and strands, and it's, as you can see in the middle slide, and they're fairly randomly laid out there, just like spaghetti. It's so the important thing is they had to make these rock shields. Rock shields got to be water's got to be able to transfer through it along with your cathodic protection system. That's how you're going to get your CP to the pipe, and not have any of this future corrosion that you can get with tape wraps and stuff like that, where you get water trapped between a wrap and the pipe, and the wrap itself is actually preventing the CP to get into the pipe. This allows the CP in. The only concern, and the one on the right is the grid one, where it's more of a less random holes and more of a consistent holes. The problem with both of these, is that they do have holes. They will go to the next slide, Travis. Oh yeah, here's a testing. This is the standard, the basic standard testing that it's called the ASTM G13 modified. Now we say modified because this was a test that was developed for rock coatings themselves. Now it wasn't as larger rocks as this; they're much smaller, but it was modified. Actually, that guy that's running the machine there is an employee of PipeSax now, but he used to work with the yellow, and he actually helped develop this testing method, Robin. And anyways, they're dropping basically up to 6 inch rock on a small plate with a rock shield on it, and it's got to pass. Next slide, Travis. And normally it's 10 passes, and I believe it's from 10 feet, and it's 6 inches smaller rocks, so they're fairly substantial. Now again, we're not not looking at denting of the pipe, which could happen with that size of rock, but we're looking at just damage to the coating. And if it can pass 10 times, it basically passes the G13. But as you all can probably realize, with the stranded rock shield and even the open grid rock shield, there's the odd time it's not going to pass because you got these holes there, and you could have a rock sitting on it, and another rock could drive it through that hole. So it's PipeSac wanted to develop a rock shield that would freely pass moisture and CP currents, but not have these holes in it. That's gonna potentially be a problem. Now, like I say, all that being said, these rock shields have served the industry very well, but we're just taking to the next step up. We're evolving this to a better product. Next slide, Travis. Might be my last slide. And here we are with Rockstop, and I'm going to let Travis take over and tell you guys all about Rockstop and how it's changing the industry. Thanks a lot.
Thanks, Jeff. So again, if anytime you have any questions, there's certainly that Q&A button at the top there. You can click if anything's catching your eye. We're certainly there to answer those questions. So that was kind of everything before Rockstop, and I'll kind of take it to everything up, including Rockstop. So when we did our own ASTM G13 test, that was kind of the first thing we looked at. And as Jeff mentioned there, it's a series of rocks from 1.5 to 6 inch rock and 40 drops total on one piece of Rockshield on one piece of pipe. So it passed all 40 drops with no problem. But one thing we like to do is kind of push the limits and see where it will break. So we went up to an 8-inch rock. Now an 8-inch rock has about twice the weight and twice the impact energy of a 6-inch rock. So it's quite a substantial increase. And even with that on the same piece, it still passed the G13 modified and even further modified. So that's kind of the point we knew that Rockstop was special, right? The impact strength was really good. The next thing we looked at was CP, which is probably the most important thing we look at when we develop new products. So we did the standard G95 test, and that passed with flying colors. And the reason for that is the permeability of Rockstop. So you'll notice with the other Rockshields, they have those big gaping holes in them, and that allows the soil to get to the pipe, which allows water and CP currents to get directly to the coating. Now with Rockstop, it's a little different because those holes are much smaller, and it's essentially the water that's allowing that passage through. So on this chart on the right here, you see that the permeability of Rockstop is better than a really clean sand or about a gravel. So the permeability will be better than that of the sand bedding and stuff that's around your pipe. So you don't have to worry about, say, water pooling up against your pipe. If the soil is moist around the pipe, the Rockstop will be moist, which is a good thing for CP. You really want moisture there, at least in some degree, to allow those currents to go through. And same thing, if the water table goes down, the Rockstop will drain as well. So this is a pretty critical slide. This is a spec-to-spec comparison of the stranded and the grid-style Rockshields compared to Rockstop. So this is all taken from online spec sheets and that, but the most important ones to look at, in our opinions, first being the G13 test. So we mentioned that before. Everyone says they passed the 6-inch standard, and that's been the standard for, since 1980s. You got to be skeptical of that because sometimes it will and sometimes it won't pass. With Rockstop, you can pretty darn sure it's going to pass even an 8-inch rock. So impact strength is more than double that of any other standard Rockshield. And the second, probably most critical point is weight. And that really ties to how people are putting this on the pipe. It also translates to cost. Weight is pretty much a direct representation of how much something is going to cost. But anyway, for someone putting this in on the field, if something weighs twice as much as another product, you can imagine how hard that's going to be to put on in the field, especially if you're draping, a big pad or a roll over, say, a 48-inch pipe. It can get quite cumbersome over the long stretches of pipe that you're supposed to protect. So, looking at, yellow stuff as it's called in the industry, it's quite heavy compared to, say, the black stuff, or as we have it, the white stuff. So pretty critical stuff. We might be a tad heavier than the grid guards, but you'll see in terms of strength to weight ratios that, we blow everyone out of the water. After that, puncture strength is pretty important. So looking at ours, we're about 7,500 pound puncture strength. Basically, it's a plunger test that goes through a material. When you compare that to the yellow or the black stuff, we're 28 to 60 times as good. So it's really magnitudes of difference in terms of performance. And you'll see again with another impact test, the G14. That's basically an impact tester that is a controlled 5/8 ball bearing that drops on a FBE coated sample of steel. And again, we're more than double the other guys. So in a nutshell, that's what Rockstop can do compared to the other guys, if you will. Now here's the yellow stuff, and just explaining how it's supplied. So all Rockshields are supplied in pads or rolls. The rolls are supplied usually up to about the 20-inch mark, and they get quite heavy after that, so they have to transfer to pads because at the end of the day, it's people that are putting these on a pipe, so they need to be able to be lifted by 1 or 2 people. Just looking at the lengths of each, so the yellow stuff goes in 30-foot rolls. Pads are 6-foot rolls, and they're not really that long, but part of the reason for that is because it's quite a heavy product. You'll see in the next few slides that the lengths will start increasing. So this is the black stuff, if you will. They go to a 50-foot roll because, again, they're quite light, and they have 7-foot pads. I'll talk about some of the downfalls of that in a few slides, but getting to Rockstop, we supply it also in rolls and pads, but we have a little bit longer of rolls because, again, we're a lightweight product. We can do that extra length, which provides more efficiency. You don't have to run back to the next pallet to grab another roll as frequently as you do with the other guys. Once you get to the large rolls, you do go down to 50 feet just to make sure it's light enough. But one thing that we do that I don't think others are doing is we supply what's called a master roll. So essentially what that is a roll for larger pipe, but you certainly can't lift it by hand. But what you can do is lift it with an excavator or a side boom. So you can take 141 feet of a Rockshield and drape it across a pipe and then install it very easily because you're not relying on manpower anymore. So it's a very efficient way to install a Rockshield, and again, it's very easy for laborers to do it because they're not really doing any heavy lifting. And our pads, I believe, are just over 7 feet, so we're a little bit of a longer pad, but kind of a similar story in terms of how it's supplied. So this is a pretty critical slide for installation. So we've talked about the specifications, we've talked about how it's supplied, and then we'll talk about how it's installed. So in terms of the Rockshields here, you can see in the top right how the typical installation is. It's a spiral wrapping method with tape. Essentially what they do is they put the padded roll over the pipe, and then they basically pass a roll of tape around the pipeline to basically connect it to the pipe. Now, it requires people on both sides of the trench, which you'll obviously see, and typically another person or even more just holding the pad in place because it's quite difficult to keep it there, especially if you're using a heavier Rockshield. Now, in the bottom right picture, under this guy's hand there, you can see that's the trench. And on the left-hand picture here, you can also see that it was installed right beside a trench. And you see all the dirt clods there where it looks probably like an excavating wheel came by and left some extra dirt. But someone's got to walk along that side of the trench and install this stuff. Maybe I shouldn't skip that slide. So that is a problem because someone is walking along the ditch side of the trench and they could potentially fall in. It certainly does happen in the field, and it's a long way to go. It can be 4+ feet. There, could be a slew of things that could occur in that situation. So it presents a safety concern. So, this method of installation has gone untested for probably 40+ years now, and we've come along and provided some alternatives to make things faster, but also make things safer because, again, it is a problem. So one of the big things about our Rockshields is that you can install rocks up from only one side of the trench. So you don't need someone on the ditch side of the trench during installation. So right away, that eliminates a person. That person doesn't need to be there just simply to pass that roll back and forth. So safety or advantage there. But we've also supplied these alternate methods of installation. So the first one we added was this quick strip installation, which is kind of like a Velcro tape, if you will. And Rockstop is a fabric material. It's plastic. It's not like a organic cotton or something like that. But you can use this Velcro-like tape to simply attach to the one side, pull it down, and attach. And it's a very sturdy bond because it's directly kind of in plane with that strip. So it's very, very, very strong. After that, we have the heat welding method, which is probably the fan favorite of our installation methods. We have a certain amount of fibers in our Rockshield that will actually melt when it's heated. It doesn't take much to heat it. And then once that's applied back down onto the other side of the Rockshield, it's a very permanent bond. It certainly can be undone. Usually you can cut it with a knife if you really need to get it off. But it's a very slick way of doing things. One thing that's really nice about it is it's, again, very strong. It's along the full length, but when it's in the trench, you don't really have to worry about, say, the backfill material undoing the Rockshield as you might see with stranded or the other grid style Rockshields. It's, again, very strong. So we'll get into kind of the nitty gritty of how it's done. Very similar with everyone else really in the industry. Once to get it onto the pipe, you just drape the pad over. With ours, you can reach under the pipe and bring it around to connect it. But if you're using the quick strip method, on larger pipes, it's obviously harder to do, but you can apply the quick strip to the other side of that and have an extra basically foot or more to grab it as a handle to bring it over. So that's a pretty slick way of doing that. Again, not having someone on the opposite side of the trench to pass the Rockshield back over. anyway, once it's at the 2 o'clock position or so around the pipe, you simply get the rock or the quick strip and bring it back down, attach it. We say to put 3 strips along the each pad, so about 7 feet, and then 4 to 8 along the adjacent connection to the next pad, just to keep it there. And that's really it. It's very quick. You don't need to wrap spools of tape however many times over. Here's an interesting video of the heat welding. I hope that's coming up on everyone's screens okay. But it's just, again, applying a quick little bead of heat. And these are our heat tools that we provide with pipe sacks. So they're a very efficient way of doing things. Hook up just to a propane tank. But it's a quick little bit of heat. And you have another person, actually the same person, can even just run their hand across to tap the pad back down. And again, very permanent connection. There is another person on the side of the pipe. This is just a demo we did, but that person certainly doesn't need to be there, nor does the guy on the left there with the little butane torch doing that. So that's kind of the 2 installation methods. And maybe I'll just talk briefly about those, but we did a field trial with TC Energy, this back in probably 2020 now. And essentially we did 3 methods of installation. We first tried the spiral wrapping method. We also tried the quick strip installation. We tried the heat welding method. Just to see how much faster it would be. So we did a 40-foot section of a 48-inch pipe. When they did the spiral wrap method, I think it took 12 minutes to install that with pads and completely spiral wrap it. When they did it with the quick strips, it took 6 minutes and 5 minutes with the heat welding. So just with our own product, which in general is faster to install, more than double the installation speed with the tape. And you can imagine why, because you're not passing a strip every, they say 18 inches or so around the pipe. But the new methods are just so much faster, they're easier, and again, they're safer. So you're saving money on many fronts with this product, and as well as overall just a better product. So again, you'll see why people are using it in the next couple slides. So probably our biggest example of people using this, and this is again, probably 2021 and 2022 was the Coastal GasLink project. So I'm sure most of you have heard of this project because it was a colossal pipeline that went through the Rocky Mountains of Canada. I think it was about 512 miles long. It was a really large 48-inch pipeline, and it was going through some really rugged conditions, right? It was going through the Rocky Mountains. They're blasting a lot of these trenches. On the left side, you can see, or I guess in the middle is, well, all of them are from Crane Hill and Kitimat. But again, really rigorous terrain. Now, TC specified with the yellow stuff, I'm sure you know what that is. They specified that a 2-inch rock could be backfilled on the pipe because they know, it's not really going to take a 6-inch rock all the time. Things happen when you introduce people and you're not in a lab environment anymore, things can happen. But with RockStop, they specified that a 6-inch rock could be backfilled. So it's a massive difference in rock size. But it allowed the pipe to get in the trench faster. It allowed the product to, get finished faster. So there's a lot of advantages, a lot of cost savings. When you look at labor, you look at protection, everything combined, it was just a huge advantage just by changing the Rockshield that they were going to use. So it worked out really well for them. Most of this pipeline was white. So it worked out really well for them. Another really big pipeline that went through almost the same area of the Rocky Mountains was the Trans Mountain Expansion Project. So it was a 36-inch pipeline, again, going through the Rocky Mountains of Canada. I won't bore you with the same information, but the main thing is with this is that we had 2 major pipelines happening at the same time using the same product. And it really speaks to our manufacturing capabilities that we have. So we supplied both of these projects that used, I don't know how many hundreds of truckloads of RockStop, but we did it at the same time. So when we used to supply, the yellow stuff back in, I don't know, maybe 2010 or so, the reason we stopped using them is because, we were offering our customers, 16 plus week lead times. And quite frankly, that just doesn't work in our industry. Typically people need things yesterday, and that's what we operate in. So we ended up making our own Rockshields. And then when we made RockStop, we kind of said to ourselves, we're not going to have that same issue. We're going to make sure that when people need it, we're going to be able to give it to them. And we've achieved that with quite a few manufacturers of this product, so we can really get it to you in big quantities. Last one I'll talk about was the REA, Regional Energy Access project going through the Appalachian Mountain Range in Pennsylvania. Pretty similar environments, maybe not as big as in terms of hills and that, but certainly very rocky. There's certainly blasted trenches in areas, and they used a lot of RockStop. Another big thing about this slide is it can be used in rolling cradles. It works really well in rolling cradles, actually. It will never bunch up like you will see with other products. It actually kind of like form fits to the cradles. It's, everyone that uses it in a cradle kind of like, whoa, that looks pretty good. Almost like it was meant to do that. So yeah, that's the last project we'll talk about there. So this is kind of just a summary slide of why even use RockStop in the first place. The biggest point would be that it's the best impact protection you can buy. It's more than double the impact strength than any competitor product, and it certainly won't let you down. It's a consistent product. You don't have to worry about, let's say, we call it like the hammer and a nail effect, where you have one of these small holes when you're backfilling, and another big rock that's, there's a little rock in that hole, and a big rock pounds it down and damages your coating, and that can happen when you have holes in a Rockshield. Another thing that can happen is when you have when the pipe moves from vibration, or you have thermal expansion, and that the pipe's going to move, and if you have many rocks against your pipe when it's moving, it almost abrades like sandpaper, and we see that quite frequently. Something you won't see with RockStop, because again, it's a consistent product. It totally shields the pipe from what's around it, and it has weird applications. In Canada, where there's carbonaceous materials that need to be completely separated from the pipe, you can use RockStop for that reason, whereas another product wouldn't work for that. So little advantage there. But anyway, another thing that's really nice about it, it's lightweight and it's easy to handle. So you don't have to worry about, or it's lightweight, so you can get on the pipe very easily. But one thing you do have to worry about with Rockshields is cold, and as well as maybe not so much heat, but when you get really cold, sometimes Rockshields get really stiff, especially the plastics. And it'll cut your hands. Even at room temperature, some of the stuff will cut your hands. But when you get to, say, minus 40 Celsius or Fahrenheit, you can get where the rocks will actually want to break, or it's really hard to get it around a pipe. With RockStop, you don't have to worry about that. At minus 40, as on the Coastal GasLink project, it was very much that cold a lot of the time. No issues getting on the pipe. It works really well for them. So that ties into the flexibility and durability, but very durable product. You don't have to worry about it, say, tearing on the pipe or unraveling once you backfill or stuff of that nature. It's a really strong product that doesn't require as much fine handling as you might see with other products. CP, again, it's compatible with CP systems. Arguably the best. We actually heard a report from TransCanada, who did a corrosion test with Corrosion Service, where they looked at Rockshields that were actually compressed underground, right? Because when you put a pipe in the ground, it has the weight of the pipe and the weight of the material on top. So when you really squish a Rockshield against a pipe, it's going to shield more. So they did a test looking at that, and what they found was that out of the Rockshields you could buy, that RockStop was the best for that. So it's kind of a nice patent for us. Reduced labor. Again, you don't need someone on the other side of the pipe, so right away you're one less person. But just because you install it faster, you actually need less people to install it. You can get away with a 2-man crew. 3 would be nice, but compared to the 4+ man crew that you're using to install other products, you'll see a labor advantage right away, and plus it installs faster. That ties into the unique installation methods we have. So because these new installation methods that we've introduced, you can get away with installing a lot faster. So when people want to get that pipe in the ground, using something like RockStop will really help you do that. And then obviously we'll supply in any roll or pad that you need to supply for your pipeline, whether it's odd diameters. I mean, we have up to 56-inch diameter, but we can go much larger than that, or same way the other way. We can supply from 2-inch all the way up to whatever you need. So last thing, this is just a testimonial, and a lot of people say really nice things about RockStop when they try it. Usually when a purchaser brings on RockStop, people in the field say, okay, hold on, we don't want anything else, because it's so much harder to install the other stuff. The people in the field really appreciate using RockStop because it's so much easier on them to use. It's faster. Generally, field people don't really like busting their butts where they don't have to, so they appreciate it. But anyway, here's what one person had to say about it. A lot easier to work with. It's a lot lighter, went on really nice. And for a first-time user, it was very intuitive to figure it out. So it really worked well. I think this is a project in California, but similar stories all around. So from here, we're certainly around to give a sample of RockStop to you. We'll be happy to send it to your office. or hand delivered. If you want a presentation on maybe all of our products, we're certainly happy to do a lunch and learn. Or if you want to book a demo, we're certainly happy to go anywhere in North America, really, to show you how to use RockStop and show you the real difference between us and the other guys. There's our email there, info@pipesack.com. If you want to email us, we can reach out with any engineering support we can offer or sales assistance. We're always there. So from here, we can open the floor up to questions. If you got that Q&A button at the top there, certainly submit any questions, and we can go over them at this time.
Thanks, Travis. We've got a few questions. I'll start going through them. The first one is, if your RockStop is heat welded instead of spiral taped like other Rockshields, do you expect that it would last longer on the pipeline? I'm thinking in areas where flooding or ground movement is possible. I assume the tape would eventually come off. Is heat welding permanent?
I can go answer that, Jeff.
Yeah, I could. Yeah, as Travis mentioned earlier, we would consider it permanent. It can be taken off with a knife. Certainly, when we come and visit your office and show you a sample of it, actually heat welded, we can heat weld a little piece right in front of you. You won't be able to pull it apart. So it's something that does not come apart too easily. So yeah, it'd be much more permanent than any other method. All that being said, something that I just want to make sure that people make sure the owning company has no problem with heat welding a product on their pipe, even though the temperature is way below anything that would cause any problem with the coating. It's something that really should get prior approval with the owning company. But no, it's a very permanent way and quick way to do it. Thanks for the question.
I've got another question. We've used Pipe Defender in the past for extreme rocky conditions. When would you use RockStop as opposed to Pipe Defender?
Maybe take that one. So Rockshields are really.
Yeah, you all right, Travis? You want to get that, or
am I coming through on your end?
I don't hear Travis.
Oh, you take it, Jeff. My mic.
Oh, he's talking, is he?
Okay. No, I think it's just a delay there. Essentially, with Rockshields, you're typically looking at a 6-inch rock and under. RockStop, obviously, it's a little better protection than that. But that's typically where you're going to start denting your pipe is over that limit when you have these really large rocks. Let's say up to 12-inch rock. Once you're over 6-inch rock, that's when you're going to use something like a Pipe Defender. 6-inch and below, I mean, depending on what your owning company will allow you to drop, is when you'll use a Rockshield. They might only allow you to drop a 3-inch rock on a certain Rockshield. So it's kind of up to that owning company to say what they're going to drop. But at least for us, it's definitely about a 6-inch rock and under. Use RockStop. Above that, you're going to use something where you need denting protection, like a Pipe Defender.
Thanks, Travis. And our last question is there any risk of damaging the coating with heat welding?
Travis, you want to answer that one?
Sure. So in short, no. At least, yeah, I mean, if you do it the way it should be, which everyone will, you won't. So we did a trial initial field trial with TransCanada. We put heat temperatures under the RockStop material. So when you're heat welding RockStop, you're not heat welding anything but RockStop. There's a really healthy overlap there. So you're really just heat welding the RockStop itself. We did a really healthy, torch of that. And I think we only increased the temperature of the coating by, 7 Fahrenheit. So it's a very minimal increase in temperature. Because you do have quite a thick material there. It is an insulating material to begin with. So you really don't apply that much heat to the coating itself. I believe you can heat a coating up to about 150 Fahrenheit for about a 2-day period. So it's really not doing much to the coating. I mean, they apply these coatings at 500 Celsius or whatever they're doing at the plant. So you're really not going to do any damage to the coating because you have, again, that 6+ inch overlap that you're heating up. You're really not going to damage it.
Great. Thanks, Travis. We just had our last question come in. It asked, when lowering in, does rock stop go through rolling cradles?
Want to take that one, Jeff?
Well, yeah, sure, it certainly does go through rolling cradles. That is a great advantage of rock stop that most of your contractors would discover. You can't do that with any other rock shields to our knowledge. Running them through a rolling cradle, they'll start to bunch up. Or particularly when rock stop is heat welded or heat sealed, it makes it that much better. But even if you use our quick strips, the mushroom tape or Velcro type strips, it still passes through rolling cradles quite easily without bunching up. So good question. Thanks.
All right, that's all the questions that we've received. If anyone thinks of any other questions later on, you can feel free to email us at info@pipesack.com. And again, if you would like a recording of this presentation, or you'd like a sample or a demo for Rockstop or any of our other products, feel free to shoot us an email at info@pipesack.com. Again, thanks again, everyone, for joining us today. We hope you found it beneficial, and we'll be in contact soon. Thanks.